that on there. When I switch to writing code, remind me, and I'll turn the projection back on here. Okay, so I want to remember, what was the theme of this week? Infinity. That's right. We'll get to beyond later. So we're going to talk about different kinds of infinite things for the next two classes. I want to start by talking about movies. I mean, I'm Indian, our movies kind of go on forever. So, anyone ever seen a Bollywood movie? Bollywood movies, or how long are Bollywood movies? Yeah, exactly, right? You know why Bollywood movies are so long? Because they're all musicals. I still remember when I first came to the US, they said that this movie is a musical. I'm like, what does that mean? It's got like singing and dancing. And I'm like, oh, which one does not? So, I highly encourage it, but only over winter break. Nobody has that much time otherwise. Okay, so I want to talk about movies, and I want to talk about animations and graphics and all kinds of cool stuff. Now, I am utterly unqualified to talk about all these things. You are very fortunate to work in one of the world's best departments to talk about these things, and if you want to learn more, you go talk to Andy or Spike or David, or you don't know these people, Andy Van Dam. Spike is John Hughes, David is David Laidlaw, Barb is Barb Meyer, James is James Tompkin, and Daniel is Daniel Ritchie, and all these amazing people. I don't know jack about any of this stuff, and these people are amazing. So, I do know some things. I'm going to tell you about those things. So, let's talk about movies. Right? Now, when we say a movie, you should already be suspicious. Right? The word movie is a marketing term. And like most marketing terms, it's a lie. Because in a movie, nothing actually moves. So even the most sophisticated movie, even the coolest, latest dinosaur movie, has to follow certain principles. So whether it's made in Hollywood or Bollywood or in class today, they all have to follow a certain principle. And that principle is that every movie is actually just a sequence of still frames. That's all it is, right? You can spend more and more and more $1 million to generate each of those frames, but you still just get a sequence of frames. And as you may know, there's a principle that basically says if you show a sequence of frames at a fast enough rate, the eye, the brain, this amazing device that we totally trust for all sorts of reasons in courts of law and so on, will totally fake you out. Right? If you just show these images fast enough, the brain will fill in the gaps between the images and let you fool yourself into thinking that there is such a thing as continuous motion. And that's what a movie is. The moving pictures, as they were originally known, were pictures that were played fast enough that they appeared to move. Does anyone know what a zoetrope is? Zoetrope, basically you take a set of frame, you take a circular image, you basically create little slits and spin it around fast enough. It's a lot of fun. It's fun to make one. And if you have a little robotics kit or something, you can actually make the robot do the spinning around, and you just have to do the drawings. It's kind of fun. So what we're going to do is in class, we're going to do the equivalent of that. Okay? There's two things I'm going to get to. And so this is going to take 2 lectures to fill out the whole content, and we'll understand where the infinite part comes from. But for today, I'm going to most probably, depending on time, I'm most probably going to focus just on making simple movies. Okay? So there won't be dinosaurs or anything nice like that, right? For all that, you have to go to the graphics course and do all the fun stuff. My focus here is not on the graphics part, but on principles of programming. That's what this course is about. So it's on the principles of programming these kinds of things. So when we want to make an animation, so maybe we want to make, I've preloaded some things. I drew a little UFO drawing for you, so we're going to have a little UFO. Let's see, where is it? I should probably zoom this in a little bit. Okay, so include image, and I'll just put this in. We'll need this later. So image URL, CS Brown EU. It. What is it? UFO.png. Okay, and there we go. We got our UFO. Okay, So, okay. So we have our nice little alien who's coming to visit the planet. So imagine that what happens is we have our alien, and maybe our alien starts off over here, and then after a while our alien is over here, and after a while our alien is over here. Okay? So when you actually do animations for real with people who know how animations work, fortunately we have people in this department who know way more than I do, like people who work in Hollywood and stuff. Okay? So they will tell you that you do this sort of thing, right? You draw out a sequence of frames that illustrates the kind of motion you're trying to show. Right? And if you take Andy's graphics class, he'll talk about principles that they use in movie making where the expert artist will draw some of the frames, and then the cheaper artist will go in and draw the built-in the frames in the middle, the intermediate frames, and that's how you make an animation. Okay? So that's what we want to do. So the way I like to think about problems like this is I like to decompose them into two parts. If you've programmed before, if you've programmed things with animations or graphics before, this will be a new way of thinking about the world. So pay attention. We're not doing the same thing you did before. What I'm going to do is to say, look, let's split this into two things. What is, and next class it'll become even more obvious why I did this split. What is the essence of this image? Put it differently, let's say I have this image and I have a background, right? Maybe I've got some mountains that my UFO is trying to dodge over here, and right? Something like that. What is variant and what is invariant between these images? What is variant is what's changing, what is invariant is what is not changing. Okay? What is invariant between these images? You might need to use your imagination with my drawing skills, but what is invariant? What appears to be invariant between these images back there?
The background.
Yeah, the background is the invariant part. It doesn't, it shouldn't be changing, okay? So the background is the part that doesn't change. And what is variant? What seems to be changing? Seems to be changing. How many things seem to be changing? How many things seem to be changing? One. What is that thing? The UFO, let's be a little more precise. What about the UFO? Is it the UFO that's changing?
The location.
The position or location of the UFO, right? Well, you haven't seen the picture, but the assumption is the UFO picture is not changing. It could also be changing, right? So what we're going to do is we're going to conduct this kind of analysis. We're going to ask what's invariant and what's variant. What is variant is the information we need to record, because what's invariant is essentially also known as a constant. We've defined constants before. Our constants have tended to be things like 3, but there's no reason the whole background of the scene could also not be a constant. Right? Make sense? So, what is variant is the position of the UFO. So, what is the critical information with which we can reconstruct a scene? That's really the question. What information do we need to reconstruct a given scene? We need one piece of information, which is the location or position of the UFO. And in this particular program, how much information do we need about the position of a UFO? Show me with your fingers. Vote with your fingers. Vote with your fingers. That's a very rude sign in some countries, just so you know. So, okay, yeah. Okay, so how many things? One thing, two things. How many vote for one? How many vote for two? Okay. Any zeros? No. Any threes? Okay. What's the one thing? One of the ones. Onesies. Who's a onesie? Yeah.
So if you consider like each little dot on the screen as like a pixel and it weaves around, it's going to be like the position of the middle of the spaceship.
Okay, so it's going to be the position of the middle of the spaceship. And what kind of thing is that?
A number.
A number. Okay, everyone okay with that? Any of the twos want to disagree? Yeah.
I think the position, I agree about the center, but it should have an X and a Y coordinate.
Ah, it's a two-dimensional position, right? My UFO is actually going in 2 dimensions, not just one. So I really need to think about my 2-dimensional position rather than a single-dimensional position. Okay? So here's what I'm going to do. All right? Yeah. Yes.
I think like the reason I voted 1 in
Ah.
particular for this case. Like, generally it would be 2 because there's 2 dimensions in movement, obviously. But in this case, you're moving along a line, and so
Well, you are extrapolating way too much into my drawing skills, dude. I understand you're infilling a lot of things given the quality of drawing, but maybe not. Okay? So, how about we decide that our UFOs don't have to be quite so constrained? Hey, UFOs, man, why did they got all the way from another planet and they go only in straight lines? What kind of UFOs are these? Okay, so fair enough. Perfectly reasonable. So, by the way, that's a very interesting point, right? The really deeper point here is it depends on what it is you're trying to model. If you are trying to model linear motion of a UFO, then in some sense the lineness is essentially a constant, right? You can think of the line's the parameters of the line as a constant, and then the only thing you need to know is where along the line is it right now. Okay? But it might be more fun if we let our UFOs roam, these are free-range UFOs or something, right? So, okay, so we have a position type, okay? And so what I want to be able to do, let's just take linear motion for now, right? What I want to be able to do is to describe 2 things. Given the information, and I'm going to use a word from now on, I'm going to use 2 words that are used interchangeably in computer science and also in some other sciences. We sometimes call this the model. The model is what is the essential information? What is the essence of this picture, of this program? The essence of this program is this. Once you tell me where the UFO is, I can give you everything else. That makes sense? That's the model. Sometimes we also call this, in reference to other subjects, the state. If you study physics, you will study states of systems. What is the state of the system? Well, it's the same thing that computer scientists call the model. So what is the state? It's what's the essence of the system? What are the critical parameters of the system? Okay. So the state or the model is just a position. So what I would like is 2 things. Given a model, I need to be able to construct one of these pictures, because ultimately our goal was to make a UFO movie. But also, given a model, I'd like to be able to construct. Well, ultimately, I've got to show you these, right? I've got to show you that sequence. But instead of just doing it directly at the level of images, I'm going to do it at the level of models. And so if I can do this, then I can also do that. And that lets me do this, which lets me do that, and so on. Okay? So I'm doing something a little indirect, right? I could have gone from picture to picture to picture. I've chosen instead to go from model to model to model, and then from model to picture. Yes? I'm intentionally doing something indirect. Okay, so first of all, I'd like you to talk to your neighbors, introduce yourself, and tell me what the function type is going to be. Well, these are functions, right? Obviously, given a model, it's going to give me a new model. Given a model, it's going to give me a picture. What is the function type of each of these functions? Okay? What's the function type of this dimension? What's the function type of this dimension? Start with that. Go.
And then the right
In 5, in 4, in 3, in 2, in 1, and we're back. What is the type in this dimension?
position to position.
Position to position? Position to position? People feel pretty good about that? Given an old position, tell me what the new position is going to be. Okay? What's the type in this dimension? Position to image. Position to image. Good. I actually told you the answer, so I don't know what you folks are talking about for so long. Okay. So we'll call this an update. Update takes a position and returns a new position. Okay? And we'll have a function called draw, which takes a position and returns an image. Okay? Okay. So what is update going to do? It's going to get a position which has an x and a y, right? So we're going to have to compute a new x, okay, and a new y. So in our UFO image, given that since it seems to be going kind of linearly across our screen, each of these is going to be updated by a constant. My goal, by the way, here is to teach you something about program design, not to teach you the details of UFO picture construction. So I'm not going to get worked up about the exact constants and so on, and parabolic motion and so on. I might do something a little fun, but that's not my goal here. Yeah.
Shouldn't update like take a function instead of
Update is going to take a position and give me another position.
no, I know, but like a position and a function that actually like describes how the motion should change.
Well, update is that function.
Oh, okay.
Update is the function that encodes, that embodies how the motion should change. Okay? All right. So what's it going to do? It's going to take p dot x and maybe it moves it over by 5. And maybe it takes p dot y and moves it over by 10 or something. Okay? Good? So far so good? Good. Now, what should we have done? Yeah?
Have we learned this notation?
Oh, no, maybe not. I'm teaching it to you now. So let me show you. So what we're doing is we're creating a data structure. So that's what this means. This creates a data structure that has two. So, okay, this is essentially the same as typing data, pause, some kind of constructor, x is a number, y is a number. Okay? But I don't have to go through the pain of creating big pause and little pause and writing pause every time. If you use this notation, you get something that's called an ad hoc object. Okay, fancy name for basically saying it's the same thing. Okay? Yes.
These brackets are different than, or they behave differently than the one we use for the thunk.
Exactly. So the key thing is if I write this followed by a parentheses, then you're creating a thunk. If I write a non-parentheses, I'd write like a letter, then I'm creating one of these objects. Okay? Yes, next question. Yeah.
If you use a type to define two different types, how would the curly braces know which type you want to make? It's not auto-recognizing everything of this shape and saying it's this. It's expanding this to be this, so that it's only going from left to right, so there's no confusion. Okay? Yeah?
How would we do the equivalent of cases for this?
You don't.
Oh.
You just pull the fields out. There's no, the whole point is data lets you define cases, multiple different kinds of things, right? So if I want to say a position is either a 2D point or 2D or 3D, I can't use this mechanism. This is a really lightweight, cheap mechanism for saving me the pain when there's only one variant, right? And I don't want to have to go through the pain of cases. Okay? So think of it as data with just one case, and then I don't want to have to go through the pain of having to create multiple names. Okay? Yes?
Is there like an is type?
No, on purpose. Yeah, good. Talk to me about this type. I've only had 2 PhD dissertations on this so far. So, it's a topic that comes up in 173. Okay, so we really should write some tests for this, right? I've just been sort of free-form coding here. So we might write where update of x is 2, y is 3, is what? What should that produce?
7, 8.
Okay, so x is 7, y is 13. Okay? And if I run the test, it comes back and tells me that it's correct. Okay? Good? Okay. So now we have to also do a drawing. Let me define a background. Let me draw a rectangle of, I don't know, 400 by 300, solid white. And so I can put image of the UFO on p.x, p.y, and put it on the background. Okay? So far so good? All right. Oh. Called a drawer. So I can do the sequence, right? I can do an update. So let's say I have an initial position. So what's my initial position for my UFO? It's going to be at the top left. So let's say it's at x is 10, y is 10. Okay. So I could say update of init
and it gives me a new position. I can call update of init. It gives me a new position. Update of init gives me a new position, right? I can also say drawer of init, right? And it puts, oh, did I get my coordinates wrong? I need to be, okay, that's fine. My UFO is going to go this way instead. Okay, so then I can say drawer of update of init. Okay, and slowly our UFO emerges. Okay, so good. There we got our movie, right?
Yeah.
I see some yeses and some nos. Okay, some of you have the same low movie making standards as I do. I heartily encourage that. But some of you seem to be a little distressed by this. Why are you unhappy? What's Wait, what? You just scroll, man. You just scroll fast enough at a time. When you were a kid, you were happy with a flip book, all right?
However, a flip book is like all compressed together.
Yeah. Okay, all right, fine. I'm not gonna pull this off. All right, fine. Okay, fine. So here's what we're gonna do. We're gonna actually define. I'm gonna teach you one new concept in Pirate. I'm gonna define something called a reactor. Okay. So reactor. This is just pure syntax. You won't be using this later this semester, so you don't have to write anything down. So it takes an initial value for the state of the system. Okay, and every time the clock ticks, and the clock is going to tick about 28 times a second, right? Because that's the frequency at which eyes don't notice, eyes fill in things. So I'm going to, on every tick, I'm going to say update, change the state in the following way. Okay? In fact, let's just see what that does. Okay? So R is just a reactor value, and it's telling me the initial value of that reactor is that's at 1010. Okay? So it just sits there. Right? It's what's called an event loop, and we'll talk about that later. But I can say interact with R, and it's going to pop up a window, and it's going to keep updating the values every 28 times a second. Okay? Okay, there's your movie. No? All right. Well, there's clearly one thing missing, which is you can also tell a reactor every time the value of the state changes, please call the drawer function, right? Make an image and do something on the screen. Right? And now if I say interact with R, now we get our UFO. Okay. Okay, and we can maybe slow down our UFO a little bit. I'll do what you guys do. Okay? There's our UFO. Okay. So, we just made our first movie. Congratulations, yes.
Are you stopping it or does it stop by itself?
Good question. Good question. We'll get to that in a moment. Hold on to that thought, okay? So, what did I just do? I just showed you an actual implementation of this. Okay? I showed you that if you write a function that does the update and you write a function that does the draw, a reactor will put these together, and even if you don't do the drawing function, it'll let you see the states, it'll print the states for you. But if you do a drawing function, it'll actually render an image and update the image and show it to you on screen. Okay? So, now you can see how we can do an animation. Now, why did we go through these two steps? Why didn't we just write image-to-image functions? Here's what I want you to do. I want you to talk to your neighbors about this. Okay? When I talk to your neighbor, this is a pure design exercise, right? I made a conscious decision to design the programming language construct to behave this way instead of the other way. So what I'm trying to get you to do is to think about why I might have made such a seemingly perverse decision, right? Why this level of indirection rather than doing something more direct? Go.
Also, it's in variant and variant aspects. If you do images to images to all the dealing with the invariants that every single has.
Do you need more time? In 5, 4, 3, 2, 1. We're back. Any thoughts? Ideas? Yeah.
Because in more complicated cases, you can have more than one variant. So in this one, there's only one variant.
Yeah.
So it's kind of.
I mean, the fact that there's just one data, the state is just one kind of thing. Is that what you mean by variant? What do you? Let's be clear about what you mean.
So the only thing you're changing between images is the position.
Yeah. Okay. Oh, there's only one varying thing,
Yeah,
which
yeah.
is the UFO position. Yeah. Okay. But it could be a much more complicated thing than that.
Yeah.
Okay. Good. So maybe the image drawing might actually become more complicated, and it might be harder to go image to image. That's a possibility. Okay.
We thought two things. First is like space complexity, because you have to copy the image every time you want to like.
Yeah, we'll put the complexity issue aside for a little while because that could be. There's two ways to think about that. Yeah.
And then the other thing that we were thinking is the data of where a UFO is isn't automatically encoded in an image. You need to like say like, okay, UFO is here. You need to attach more data to it.
Yeah.
And
So okay. So we'll get back to that point. Yes.
Yeah, we were saying that it just makes it easier to access moments in time. So you don't need to like look what's happening like the moment before something.
Yeah. Okay. So accessing moments in time. Okay. Yeah.
We're saying you basically have to go like down, over, and
Yeah.
like,
Yeah. We'll get back to that. Yeah. Yeah.
It's just like if you store the whole image, you're just getting a ton of information you don't need because the background.
So
never
maybe
changes.
it's redundant. Okay. So it's related to space comment. Yeah.
I mean, so you can reuse it and utilize it in other cases.
You could reuse it potentially in other cases.
You can't figure out everything in the next image from the previous image.
Yeah, so there's a few themes that are coming up here, right? So one is about space complexity and how much you're holding on to, and I'm going to defer that for the moment. The other one is, if I gave you this image, how would you get to this image? Right? You did this, right? I saw you doing this. That's the essence. That's one of the essences of the problem. From this, I'd have to go searching for a UFO image, first of all. It's not actually easy at all to find the UFO, especially what if it's occluded? Okay, I'm sorry, occluded means hidden behind something else, right? What if this mountain range actually is drawn in the foreground so the UFO sometimes goes behind? It's not even visible. It's actually very hard to go from the image to the image. It's the obvious thing, it's extremely difficult to do that. But I'm going to give you another reason. So everything that everyone said is actually completely valid. There was nothing that I would say is an incorrect answer. And I'm going to give you one more reason, which is if you wanted to debug this program, it's much easier if you actually have access to the raw data, because there's actually debugging a visual program like this involves two different things. Sometimes the bug is in the rendering of an image, and sometimes the bug is in the logic of the update. And if everything is put together as one thing, you no longer have the ability to separate those things out, but you will be forced to separate them for the purpose of trying to isolate the bug. If you have done graphical programming before, or if you go look at what happens in CS15, let me tell you something they never do. Testing. You can't test. It's really, really, really hard to test, because your test cases are this monstrously big image is equivalent after one step to this monstrously big image. Okay? Which is fine. First of all, like, how do you even state the images? How do you draw the images? But it's more subtle than that. Image equality is really difficult. Sometimes slightly different ways of rendering an image can cause one pixel to be off. There's a whole course about that. So you go take the pixel course, right? 123. One pixel could be off, right? There's like there are aliasing effects. What are called aliasing effects. There are various rendering effects. The order in which you drew things means this pixel might be more salient than that pixel. But image equality means the pixels are the same. So, of course, that's not what you really want. So then you have to define what it means for images to be equal. And then how do you get the stream of images? There's some video stream, and somehow you get The complexity of testing the programs is mind-boggling, and the simple solution is just don't do it. Well, that's not the goal. That's not my goal. My goal in life is to get you to become good software engineers, which means you also know how to test your programs. Here is what you accomplish here. I mean, I of course did exactly the wrong thing, which is I deleted my test, right? Just for the laughs. But the point is, you can write tests on update with all of the knowledge you have this semester. Testing update is nothing special at all, right? Update, the update function, could have been, I could have given this to you in week 1 of the semester. Maybe if I taught you something about the syntax language, it would help. But, you could have done it with the data structure or something else, right? Update is just a boring old function that you already know how to program, already know how to test. You could even write an oracle for update. Yes? What that means is that if there is now a bug, much more likely the bug is isolated to the rendering part. You can still write tests, right? You can also write tests for drawer. You can say for this particular well-known input, this is the image I ought to get. Or you could do visual inspection, which is what you usually do, right? But the point is we've now separated our concerns between the updating and the rendering, and one of them becomes easy to test extensively. You can even just comment out, right? You can just say, you know what? I wish I could just see the values that are going by, right? And you can just see the values that are going by as they go by. And you can bring the drawing back in or not. There's actually, in Pirate, we also have another form of interact called interact trace. And if I run interact trace, so if I run it instead of deleting it, I run it for a while and I'm going to hit escape. What it actually gives me the table of all the values. So I can see the animation, but I can also get the table of all the values, and now I can go back and debug these. Actually, tables are values in Pirate, so I can then write programs over the tables. I can say, go find the first point in the table where something weird happened. Go find me the tick at which the first weird thing happened. I can do that. I can programmatically try to debug my image programs. Okay? But the principle I'm trying to teach you about the separation is actually a very well agreed on principle in software engineering. It's called the model view controller paradigm, and it's kind of the standard way. If you've heard of things like React and things like that, all these like hip web APIs, they're basically trying to make JavaScript programmers grow up. Okay? To program more in a model view controller state. So you have a model, you have a view, and a controller that coordinates all of these. And model view controller came out of actually software systems in the 1980s. And the idea was, people said, look, let's say what I have is, I have some data, and I want to visualize it in 2 different ways. I want to show it to you as a pie chart, and I also want to show it to you as a table. Okay? But when you update one of them, I want the other one to also update. Pretty natural, it's what you would expect. Well, how many communication channels am I going to have? Is the table going to have to know about pie charts, and pie charts are going to have to know about tables? They're written by 2 completely different teams in the software company. They don't know, they have completely different sets of expertise. And what if I add a third kind of visualization tomorrow? Am I going to have to update all of those talking to each other? That becomes a quadratic number of connections. When you see quadratics, try to make them linears. Yes? How do you make it linear? Well, you have all of these different views, and you have a central model. And each of these has a bidirectional communication channel. And so when there's a change to the model, it broadcasts to all of the views, hey, I've just updated. I've changed. Anytime one of these, like maybe it provides a slider or whatever, button or click or something, every time it does that, it broadcasts an update to the model, and then the model sends everybody else what to do. Okay? This is how real software is built. This is just, take it as a given, right? Pretty much the only way to build scalable, maintainable software. That's what I'm trying to teach you here. I'm teaching you the model view separation. There's model update, there's model to view. We could have multiple views. For simplicity, we have only a single view. But you've already seen, if I turn off on to draw, you get one view. If I put on to draw, I get a second view, right? One is provided by default by the language. The other one is generated for you by your own program, right? You could imagine running both of those at the same time. And I've actually shown you a third view as well.
which is the after the program has stopped, give me the list of all of the ticks as a table. That's 3 different views, right? So model to multiple views, and the controller is something we've written for you in Pirate, so you don't have to write it yourself, keeping all these things coordinated. Okay? So I'm actually trying to get you to the essence of how you would build larger systems. Question back there, yeah.
Oh, yeah. So is controller interact?
Yeah, controller is the thing sitting behind interact. Yeah, yeah. Like something is basically recording something is, right now the controller is doing something very simple. It's keeping a clock running, right? You didn't write any clock code. You just said on tick. So it's generating a clock, it's starting up a clock. On every clock tick, it's calling the appropriate functions in the appropriate order. It's calling the model-to-model function, the update. It's checking whether the update changed the state. If it did not, it actually leaves the image alone. If it does change the state, it calls the toDraw function, the drawer in this case, calls drawer, gets a new image, replaces the old image, puts the new image in place. All of that is being done by the controller. Yes?
Can you draw and then update?
This controller will not let you do that. So this controller is designed, we made a conscious decision to say you should not redraw the screen unless there is a change of state. So we do an initial drawing of the initial state, that's within it, and after that only if update causes a state to change will it do a redraw. Okay? Which is really what you would want as a programmer for the most part. But then you can write your own controller instead. Yeah?
Can you put multiple functions into OnTick?
Can you put multiple functions into OnTick? No, that would be very confusing to OnTick. Right? It's tempting to say, well, maybe I want multiple things there, but then OnTick would not know which. Here's 2 problems. First of all, what order am I going to call these in? Secondly, whose answer do I take? If you say all of them, well, how do I combine the answers? It's like saying a function has multiple expressions in its body. Which one's the answer? Right? Do I do them in order? Also, if each of them does a partial update to the state, then if I start to redraw, I might get completely nonsensical state, right? I might want, like let's say I have a separate function for the x and a separate function for the y. Okay, an x update and a y update. So what might happen is my UFO might go like this. Because it did the y update, then the x update, then the y update. But that would be nonsensical, right? I never intended to see that intermediate state. I only want my UFO to go like this. Right? So if I did that, then I would be showing you states that don't even make sense. Coherence of state is a really important principle. Okay? Yeah.
Can you combine separate functions into a single one?
Could you? Do you think?
Sure.
Yeah. So you could be right here, and you could say, well, I have a big complicated way of updating x, and so I'm going to call a function there. I have a complicated way of updating y. Call a function there. The principle is function composition is always good. You're welcome to knock yourself out doing it. Make sense? Good? Other questions? Okay. So, I mean, and you know, we could do more fun things too, right? We could say maybe it doesn't change at all in the x, but p of y is, I don't know, we could say, let's start in the middle. 200, 150. P of y is, I don't know, we'll add like a random of 10. That, and if we do that, okay, all right, good. You can do that, and you can imagine having a list of UFOs. So the thing is, again, there's nothing about the reactor that expects your state to be one particular thing. It could be a list of UFOs, it could be a single number, right? You see, nothing in the code cares, it's all agnostic. There is some type T that is the state of the system. In it has to be given a thing of type T. Update is T to T. OnTick gets a T to T. toDraw gets a T to image. Whatever T is. We actually use this to teach a physics curriculum in high schools, and in the physics curriculum pretty much everything is like, you know, it's a XY point and it's like a delta X delta Y for a vector. Okay? But we use this to do, we use this in an algebra curriculum, and there we might have much more complicated structures, right? And reactors don't care. They are polymorphic,
Okay? Just like map doesn't care what type of thing is in the list, reactor doesn't care what kind of thing is in your state. It's like I'm agnostic to the state. So I want to show you two more things before this will set up for next class. One is, you asked me like how is it stopping, right? It's actually stopping because I'm hitting the escape button, okay? Equivalent to hitting the X. But that's not good. Maybe I want to stop my UFO from, flying off the screen. So what we can do is also say, define a stopper. What do you think is going to be the type of stopper? What do you think it's going to be its type? Okay, talk to your neighbor. Talk to your neighbor. Go.
I think it's sort of straight, and it'll either be a string that's continuous or a string
Okay. 5, 4, 3, 2, 1. Back. What's its type? It clearly has to produce a Boolean. Right? That much we can all agree on. It's got to say, am I stopping or am I not? And what is consume? Consumes the state of the world. Always consumes the state. Okay? So, we can run this.
Call the stopper.
Yes, thank you. Good. We'll see if anyone noticed. So we didn't actually tell you how to call the stopper. Okay? To stop is stopper. No, to stop when, thank you. Okay, somebody seems to know what's going on. Stop when, sorry. Okay, good. And now if I try that, then hopefully my UFO will do something. Come on, come on, come on, come on. Come on. Okay, so now it has stopped. It leaves the image, that you can say it close the image when it's done if you want, but it's going to leave the image up. So I'm still going to have to escape, but the program has now stopped. Watch what the return value is. Interact always returns the last state. You may not have noticed that before, but Interact always returns the last state. And so now we're going to get a state and we'll see that y is now -1. Okay? So if I didn't do that, if I just hit escape, it's going to say, you were right about there, right? It had gone down a little bit. Okay, question.
So it stops after the update has caused Stopper to do things?
Yeah.
Not like before?
So this has a well-defined semantics that's pretty simple, and then you could always imagine defining something a little more complicated where your updater chooses to not do an update, but sets a flag in the state saying, I'm ready to stop, and the stopper just looks at the flag.
Okay.
Right? That's your choice. You have choice of data structure. Okay? Okay, one last thing I want to do. You can also make it respond to keystrokes. So let's say typer is it's another state update function, just like the ticker is. So I could say something like and what do you think the type of this is? Is that a good type? Why not?
How do you accept the key?
You don't know what got typed. Okay, so if I could say is k equal to it's con. Okay. Okay. Right. So if it's up, then what I might say is x is the same as p dot x. But y is now p dot y plus 10 maybe, right? And x is p dot x, y is p dot y minus 10. Okay?
Do you need an else?
I do need, okay, good. Okay, and now you can see that nothing's happening because I forgot to actually call it. On key is a typer. Okay, and so you can see I'm hitting the up arrow, hitting the down arrow, hitting the up arrow.
What if you hit a different arrow?
Yeah. What if I hit a different arrow? What if I hit the space bar? What's going to happen? It's not going to do nothing. It says I have no idea what to do. It doesn't, we don't, it's not a language that makes up crap for you, okay? So what do we need to do? We need to say, otherwise, what? The state has not changed. I can't say hi. If I say otherwise hi, it will get very upset at me. Here, we can try that. Good. So, the way you say the state has not changed is you say otherwise the state variable. Okay? So now I'm hitting the left arrow and the right arrow and they're having no impact at all. So that pattern is how you say, and in all other situations do not change the state. Okay? So, we have a t, so init is of t. It's not, init is not of type, init takes a thing off that type. Okay? On key, on tick is a t to t. On key is a t comma, basically a key to t. Okay? To draw is t to image. Stop when is t to boolean. Okay? So basically this is input, this is output, this is execution control. And we've had this, we've run this on other platforms where we have more things. So on, this is basically any kind of stimulus, okay? So you could imagine a networking stimulus on network packet, on, on tilt, right? If you're running it on a phone. And the two similarly could have other services. So you could have, when we run on a phone, it might have a to SMS. And that function, whenever it's called, it basically might generate a string, and that string is sent out as an SMS message. It generates actually a string and a number to send it to, and it sends an SMS. Okay? So different kinds of input, different kinds of output, execution control, initial value, and now you get this extensible framework for being able to do different kinds of interactive input-output systems. Okay? Questions so far? Next class I'm going to build on this. I'm going to try to talk more and talk about some other ideas as well. Good? See you next class. By the way, if you like this kind of stuff, go take a graphics class. As I said, there's a bunch of people here who do really cool stuff. Andy and Spike and Barb and David and James and Pedro and Daniel and like infinite number of people.
Sally and Martha, Steve.